All right, a 13-foot ladder rests against the side of a house. When the base of the ladder is 5 feet from the base of the house, it is moving with a velocity of 3 feet per second away from the house. Determine how fast the top of the ladder is moving. So I'm going to label the bottom X, the top Y. Is the length of the ladder changing? No. So since that length of the ladder is not changing, I can go ahead and call it 13. Now, if that length was changing, I'd have to put in Z and plug in the 13 after I took the derivative. But the length of that ladder is not changing. So my equation is going to be x squared plus y squared equals 13 squared. Derivative 2x dx dt plus 2y dy dt equals what? 0. It is so hard to get, I mean, like if I just ask you to take the derivative of 5x squared plus 3x plus 2, you know that the derivative of that 2 on the end is a 0. But as soon as you start doing this, there's so many careless errors of not making the derivative of a constant equal to 0. So be careful with that. All right, let's identify some variables. What's x? 5. And the length of the ladder is 13, so therefore y has to be 12. You can use the Pythagorean theorem, but those of you that recognize that that's a Pythagorean triple, good job. The base of the ladder is moving 3 feet per second away from the house, so what variable is that? Good, dx dt. And is it a positive 3 or a negative 3? Positive 3, because if this ladder is moving away from the house, then that length x is increasing. And then I want to find how fast the top of the ladder is moving, so I'm trying to find dy dt. Okay, you're not... It's sliding down. Like the top is going down the wall, and therefore the base of the ladder is coming out. It does defeat the purpose of a ladder. Okay, so plugging everything in, we have 2 times 5 times 3 plus 2 times 12 dy dt equals 0. So 24 dy dt equals negative 30. Dy dt equals negative 30 over 24, or negative 5/4. And really, you're welcome to leave your answer as negative 30 over 24 because you do not have to simplify on the AP exam. I've been teaching this for 6 years, and I still forget that negative 30 over 24 is really a perfectly acceptable answer. Okay, what would the units be? Yeah, feet per second. Does it surprise you that dy dt is negative? No, because if the base is moving outwards, then the top is having to move down, so the length y is decreasing. Okay, determine the rate at which the area under the ladder is changing. So we're talking about this area all in here. So what do I need to do first? Get an equation for the area. So in terms of the variables that I've already used right here, what's the area of the ladder? 1/2 xy. So when I take the derivative, let me get some more room here. Go ahead and take the derivative. What we have to do to take that derivative? Product rule. So dA dt equals 1/2 y dx dt plus 1/2 x dy dt. And we already know x and y and dx dt and dy dt from the previous problem. So if you plug all those values in, you get 119 over 8. But what would the units be? Feet squared per second. Good, because we're talking about the rate of change of area, and area is measured in square units. It's yeah, Harry. Will you hold on just a second and let me make sure I get or but 1/2 is a constant and xy is a product. Oh, so you were using 3 products? That's fine. All right, find the rate at which the slope of the ladder is changing. What's the slope of this ladder? Okay, well, at that instant, it's 12/5, but in general, the slope is y over x. It's just rise over run. The slope of this hypotenuse right here is the rise over the run, and I'm going up y units and over x units. So m equals y over x, and then you would take the derivative, and you could either use the quotient rule or the product rule and plug all of that in. Okay, we're going to stop there and move on to the next one. Well, at that time on B, the area is actually increasing. And it will increase and then it will actually decrease. Yeah. Just if you look at the diagram, then the slope is rise over run. So you're going up y units and over x units to get from the bottom of the ladder to the top of the ladder. No, well, no, it's y over x because the 12 and the 5 are both changing. So at first you have to call it y over x, and then you have to take the derivative using y and x. Yeah, today is basically all triangles. Okay, the last type of problem is a shadow problem. Hank is 6 feet tall, and he's walking away from a light source in a parking lot at a rate of 4 feet per second. And the light is that 18 or 16? 18. So the light's 18 feet tall. Hank is 6 feet tall, and he is walking away from the light source. So what we're going to have here is a triangle. 2 triangles, actually. Now, as Hank walks away from the light, he observes that his shadow is moving. Determine how fast the tip of his shadow is moving. So basically, we want to know how fast the tip of the shadow is moving. So, yeah, I know that was okay. And he's walking away from the. Okay, sorry. I was trying to go back to this. He's walking away from the light at a speed of 4 feet per second. So that's the derivative of his distance from the light, right? So what we need is a variable that represents the distance that Hank is from the light. So you've got to let x be that part right there, right? Just that little part right here. And then we're going to let y be the whole length of the other side, or the whole base of that big triangle right there. So tell me a relationship between x and y. I have two similar triangles here. Okay. 18 over y equals 6 over y minus x. Because I've got the big triangle right here where 18 is the height and the base is y. And then I've got this little triangle where the height is 6, but the length of the base is y minus x. All right, now, how fast the tip of the shadow is moving, that's the rate of change of the distance of the tip from the light source. So I'm looking for dy dt in part A. Now, to make things easier, instead of using the quotient rule twice, cross multiply. So 18y minus 18x equals 6y. Can I simplify it even further? Sure. How about 12y equals 18x? Or y equals 3/2 x? The 4 feet per second is how fast Hank is walking. So it represents the rate of change from his distance, the rate of change of his distance from the light pole. Right, so dx dt is 4. So if you take the derivative, dy dt equals 3/2 dx dt, and if you plug in 4 for dx dt, then you get that dy dt equals 6 meters per second. Okay, so back to the question. Is it feet? Yeah, feet, sorry. Back to the question of why dx dt is 4. Okay, I'm not sure everyone does, though. So Hank's walking away from the light, and he's walking away from the light at a speed of 4 feet per second. So speed is the derivative of distance. So you've got to let a variable be the distance between the light source and the the person's speed is the derivative of that. You will always, 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 if you can always set up these problems with x being the distance between the light source and the person and y being the whole base of the big triangle, you'll always get these problems right. Why are we trying to find what? Well, part A, I'm trying to find the derivative of all of y. Part B is to find how fast the length of the shadow is moving. So part B is find how fast the length of the shadow is moving. Well, what's an expression that represents the length of the shadow? Y minus x. So dl dt equals dy dt minus dx dt, which is 6 minus 4, or 2 feet per second.